How do we compute the differential of the inverse sine of u over t, where both u and t are independent variables? Let's say w equals the inverse sine of u over t. So w is a quantity that can be explicitly expressed in terms of two independent variables, u and t. As a reminder, the total differential of w encodes how changes in u and t affect the change in w. To compute the total differential of w, there are two approaches. Here's the first one, which is analogous to computing derivatives using the rules of differentiation. To get started, we can directly take differential of both sides, and then we will apply chain rule to evaluate the right-hand side. But wait, I don't quite remember what the derivative of the inverse sine is. So instead, let's get started by taking sine of both sides. Now we take differential of both sides. Differential of sine of w is cosine of w times dw. To evaluate the differential on the right-hand side, we apply the quotient rule for differentials. Divide both sides by cosine w, we get an expression for the total differential dw. So as you can see, what we have done so far is just like what it takes to find the derivatives of the inverse sine of x using implicit differentiation. All right, notice that we have a part that is not in terms of the two independent variables yet. So let's construct a right triangle based on the expression for sine of w. Then from the diagram, we can write cosine w as the square root of t squared minus u squared over t. Plugging that into the expression for dw, we get this. Finally, by splitting the right-hand side into two terms, we can express the total differential of w in terms of the differentials du and dt. This is it. Now, as a quick aside, if you compare the du and dt terms with the general expression for the total differential dw, we can get the two partials of w for free. From the du term, here is partial w partial u. From the dt term, here is partial w partial t. Other than that, we're done with the first approach. Now, in case you don't like this approach, you may take the second approach, which is more formulaic. We first get the general expression for the total differential. In this case, we have dw equals partial w partial u times du plus partial w partial t times dt. Then all we need to do is computing the partials. This is quite the opposite to the first approach, in which we don't compute the partials explicitly, and we can deduce them from the total differential if we wish. All right, problem solved. I hope you enjoy this video, and I'll see you in the next one.